Okay, so we will solve questions. This is a past midterm exam, midterm 224. Mm, let's start from chapter 6. So that's fresh in our memory. So I will go to the last one, maybe chapter 16, first question on chapter 6. Where are, okay, talk. Figure shows 4 locations of the fulcrum along a red bar upon which 4 forces of any magnitude but not 0 act. Which of the 4 cases cannot be in rotational equilibrium? Similar to the question that we did in the slide. So you know how to go about it, right? I mean, we look at it. Is there any both positive and negative torque are there? If we get at least one positive and one negative, then we can say it is going to be rotational equilibrium, because we can adjust the sizes of the forces such that all the counterclockwise forces, torques, is equal to sum of all the clockwise torque. Since we have the freedom of uh, changing the size of the force. Let me maybe zoom in a bit. Okay. The figure is not very clear, but anyway, so the fulcrum is here. The fulcrum is here. And these are the forces. We cannot change the orientation of the force. We cannot change the location of the force, but we can change the size of the force. So let me start with this one. What is the torque from this force? 0. Very good. And this one is positive or negative? About this positive, okay? Anyone cannot follow it, please raise your hand. I will explain more detail. If you are following it, fine. Okay. So it's like put your finger here and imagine this is the only force. Which direction would it turn about that fulcrum? It's very clear. It is clockwise, so negative. You say negative, right? Okay, right. And this one is positive, and this one is positive or negative? 0. Why is it 0? No perpendicular component or parallel component. Another way of looking at it, the angle between R will be this, right? From this to this point, and F is this. They are in the same direction. That means theta is equal to 0. Sine 0 is 0. Or we can simply say it has no perpendicular component, therefore the torque is 0. Anyway, we don't have to go that far. We shouldn't waste time. You saw one negative, one positive. That's it. End of the story. He is out. That means it can be brought to equilibrium. The question is, cannot be in rotational equilibrium. He is out. This can be brought to equilibrium. Then we can go a little faster. Right. Tell me this force, positive or negative? Torque from this force about this point. It is? No. Positive. Can you see it? This is the fulcrum is not in the corner. It is here, right? And the force is here. So it is going to turn. Look at it. All right. It's going to turn counterclockwise. So it is positive. Right. So this one, negative. This one, positive. This one, why do I shouldn't, where is the fulcrum here, right? It is 0. You know why is it 0, right? It is 0 because no perpendicular component to the R. Right. So again, I don't have to go that far. I should have stopped it. Okay, the moment you see there is one positive, one negative, you stop it. Okay, he is gone. So let me go a little faster here. What about this guy? positive. This guy is 0, this guy is 0, this guy is 0. Ah, here there it is. We have one positive, no negative. So that no matter what you do, you cannot bring it to rotational equilibrium. So that is the choice. If you want, we can just, we are learning, so it's no harm because we are not in a real exam. Let's go through this as a learning process. So the fulcrum is here. So let me very quickly tell me, okay, let me start with this. Is it positive or negative? Positive. This one, positive. This one, negative. This one, 0. So we have one positive, one negative. He's also out. Right. So the answer is C. Number 17. So now you have an idea about the torque, how to get the direction. Now let's go numerical, how to calculate the torque. It's a basic question, just one force. And the question is, you really have to read it, but I will go direct to the question without reading it. Force 20 Newton, so this is 20 Newton, is applied on the bar at the point B. If the angle alpha is given 60, find the torque acting on the bar due to this force about a perpendicular axis passing through the point C. This is very important because we have so many points. Okay, it may, we don't worry about which is the pivot point. It is not, it's immaterial. Okay, the question is find the torque of this force about the point C. So for us, we just can imagine, okay, that is our rotation axis. Okay, it may not be the rotation axis. We have to find the torque of this force about this point. Okay, this is the point. Okay. So I'm going to get rid of this so we don't get confused. So we focus on the point. The point is C. That is the first thing, okay? Don't jump to conclusion. So imagine, okay, since I solved a question with the point A in a question, it's not that every time the question is going to be take the torque about point A. You have to read the question and convince yourself the correct point. So take the torque of the force F. There is only one force. So take the torque of that particular force about the point C. It's a basic, straightforward definition question, whether you know how to calculate the torque. So let me go to the basic then. The torque magnitude is only the magnitude. You can either say like this, or you can say like this, or you can say like this. You see this in your slides of presentation, right? So RF sine theta, okay, you know what R mean? R is the distance from where you want to take the torque, that means point C, where the force is applied, that is point B. So the R will be here, this one. You want the torque at the point C, and by the force F. So the force is applied at B. So R will be the vector drawn from C to B. So it has a direction. It's a vector. This is the R. But anyway, we want only the magnitude here. So, usually this is the easiest way to get the answer. So R, we know what is R, 25. So you substitute 25. I'm going by this. And perpendicular force. Perpendicular to what? Perpendicular to R. So that means this. We have to take the component of this force, so this length of this guy. So if this is 60 degrees, so the perpendicular component will be, because given with along the R, so it will be F sine 60. Okay, alpha there. The theta is alpha there. You don't look for where is theta. You're not going to do that, okay? You can label the angle anything you want, okay? You should be able to pick the correct angle. So what is it? F is equal to 20 sine 60. So that's the magnitude. We are not done, right? This is the magnitude. Then you have to decide the correct sign. So what is the correct sign? How do you do that? Imagine you put your finger on the C because you want to fix it, and imagine that anyway it's the only force. So when you pull in the direction of the force, which direction will it turn? So remember, you are pressing on the C, you're going to fix the point C. It will turn anti-clockwise or counterclockwise, so positive. So I don't know what is the answer. Somebody help me, if someone with a calculator, or you want me to use my calculator. Right. So 25 multiplied by 20 multiplied by sine 60. 133. Do you have it? What did I do wrong? Maybe centimeter meter thing? Yeah. Okay. Sorry. Okay. So I should have converted the meter centimeter to meter. I didn't do that. So what should I do here? Yeah, you know, the answer is A, right? Why is it negative? It's about C, right? Yeah, E is the answer. It's positive 4.3. You know why I got 433? Because I did not convert the centimeter to meter. So you divide by 100, so it will become 4.33. Good. Okay, let's go to the next question. Let me get him out of the way. So this is a statement question, easy one. You know what is translational equilibrium? What is rotational equilibrium? Condition for translational equilibrium is, what is the answer? C, right? No, sorry, E. Not constant. Net force is 0. If the question is rotational, what is the answer? A. Right. Yeah. Back. Okay, good. How is it positive? Okay. Right. Now, imagine yourself, you put your finger on C, so you're not letting the C to move, because I want the talk about the point C, right? So imagine this is the rod, so I am putting my finger on C, then the force is this side, right? Okay. Which direction, from your point of view, which direction is counterclockwise? Counterclockwise is positive. You know the clock can rotating. You know, even if it is not given, that is the convention. You know what is the meaning of convention? We all agree. Counterclockwise is positive, clockwise is negative. You know, probably we may not even say this, okay, but you know. Okay, now we are in question 19. So again torque, but this time we are adding more forces. Each force will have a torque. A massless bar is held in horizontal position by holding it at the left end. It is pivoted at point P, and two forces F1 and F2 are applied, and the values are given, the angles are given. To find the net torque acting on the bar above the point P at the instant the bar is released. Okay, so somebody is holding it here. So there will be force where he's holding it, but I don't want the torque from the hand because he's going to release it. The moment he has released it, there will be no force there, right? So it is going to, if there's a net torque, now the net torque is 0 because I'm balancing the whole thing by holding it. So there will be enough torque here to cancel the net torque to be 0. The moment I release it, the only force will be whatever is there, F1 and F2 only. So he is asking us to find the net torque from this F1 and F2. Just do it, right? Torque from force 1 plus the torque from force 2. So this is the net torque. Yeah, but actually here also there will be force, right? At the pivot point, because it is being hinged, there will be force at the pivot point also. Why I didn't bother to put it, torque at the pivot point, all the forces at the pivot point. This is what it should be. There are forces at the pivot point because, it is being fixed there. But the question is to find the torque about that particular point. So any force that is acting at P will have zero torque. Okay, got my point? So that's why, because we want the torque about the point P. There will be several forces there, the reaction, it is being fixed there, but those forces will have zero torque, so the net torque, this will be zero, so we don't have to worry about the forces at that point. So now we only need the torque 1 and torque 2, right? Shall we start with the F1? Okay. What is, let me just for the sake of learning purposes, R1 will be this, right? F1 will be this. Well, F1 perpendicular. F1 perpendicular. And the sign, tell me the sign. Is it going to rotate it clockwise or counterclockwise about the point P? Clockwise. So, negative. Right? I'll put the values later. So, let me go to the F2 now. For F2, right, for F2, I'll say R2. Show me what is R2. From the pivot point where you want to take the torque to where the force is applied. So this will be R2. And F2 perpendicular. Positive or negative? Counterclockwise, right? So positive. This one you have to get it right, okay? From the look on your face, you're fine, right? Okay? It's not difficult. You have to get it right. Please, tell me if I need to explain again. Just visualize, think you put your finger on the point P where you want to take the torque and forget about F1. Just imagine F2 is the only force. Which direction the rod will turn? Counterclockwise. So positive. Okay, right. Now let me put the values in. Somebody help me. R1 is 0.1. So please remember, because we need in SI unit, so it is not an equation, so that they don't cancel either side. We just have to convert the centimeter to meter. 0.1, 10 centimeter will be 0.1 meters, and F1 perpendicular will be 40 sine R. That's another thing. Okay, this is another thing. We need the perpendicular component, right? Perpendicular to R. The F is making an angle of alpha with R or the alpha that is given to us. It is this angle. Is it the angle with the vector R or with the perpendicular direction to R? Yeah. You want to show how it is counterclockwise? Okay. I wish I have a long stick or something. No, never mind. Right, look at this. Who asked this? You asked this, right? Okay. So this is the rod, and P is somewhere here, right? The point P is somewhere here. And you apply a force. You have a pen or something? Okay, give me it. Yeah, okay. Right. This is a long one. Okay, right. Fine. So this is the rod. And let's say the P is here. Okay, where I am holding with my finger, that is the point P. And your force is like this. Forget about F2, F1. So just imagine F1. So you're going to pull this bar in this direction. How do you think it will turn? Will it turn this way or that way? Counterclockwise. So that's all. You got it? Okay. Yeah, think the same way. So the point P is here, and your force is here. So I'm going to pull like this. When you pull like this, which direction is going to turn? Is it going to go? It has to either go this way or that way. So it is going to go this way, which is clockwise. So negative. Okay? What's the problem? There's only two directions it can turn, either clockwise or counterclockwise. So if the force is applied like this, you tell me, is it going to go like this or like this? Oh, what's the problem? Okay? It's fine? Okay, all right. So calculation. 40, yeah, the alpha. Now, again, pay attention, please, okay? Right. The angle that is given is this angle, 30 degrees. It is not the angle with the vector r, but with the perpendicular to the vector r. So the component will be f1 cosine alpha, not sine alpha. It's like the finding the x component, y component, because if you have a vector A, if this is 30 degrees, this will be 60 degrees, right? So you can say the x component is A cosine 30 and the y component is A sine 30. At the same time, I can say y component is A cosine 60 and the x component is A sine 60. They are all correct. Okay, so because the angle that is given to us is not the angle with the vector r, okay, not parallel to the r, but to perpendicular to the r direction. Therefore, the perpendicular component will be f1 cosine alpha. Plus r2 is how much? 50? No, not 50 centimeter. Tell me how much is r? 50 minus 10, right? 40 centimeter. And the angle beta is with the r. So it will be f2 sine, how much is beta? 30. So you just take your calculator, work this out, and you should get the answer. Let me do it for you. Okay, you go like this. Okay, there is a negative sign. Let's use this negative. 0.1 multiplied by 40. Is it 40 or 0.4? Yeah. I put 40. Did I mess up something? R1 is not 40, right? It's 10. I don't know why, how did it become. Oh, this is the value of the force. 0.1. Value of the force, F1 is equal to 40 multiplied by cosine 30 plus 0.4 multiplied by 10 multiplied by sine 30. That's it. Press the equal button. This is not solving, it is calculation. But it's, what do? I press this ST thing. So minus 1.46. Do you have it? Yeah. I think it is A, right? Round it to two significant figures. So carry one over. So it is minus. Right. Let's go to the next question. How much minimum force N1 must a man of mass 68 kilogram exert on both hands in order to do a push-up placing his hands at the chest level? All the distances are given, assuming that his body center of mass is 1 meter from his feet. So you can just, put him like a rod, and the forces acting on him is N1, and there'll be this force, let me call it N2 at the support. And here is weight, W. And the question is to find, what are we supposed to find? N1. Find N1. What is the value of N1? This is the question. Do we know N2? We don't know N2. Do we know W? Yes, we know the W because the mass is given, so it will be 68 multiplied by 9.8 Newton. Right. We have two unknowns. Is that an issue? No. We can answer this question. Tell me how. So I'm going to say this is point A. I'm going to say this is point B. I'm going to say point C. It goes straight to the rotational equilibrium condition. What is this rotational equilibrium condition? Tell me. Net torque equal to 0. And as I told you before, you need to, whenever you say about torque, you need to choose a point. It is valid for any point. If it is in equilibrium and the rotational equilibrium condition, you can apply to any point you choose. Which point should I choose to get the A, B, or C? A, O, C. All right, let's say I took A. The torque from N2 will be 0. But our question is to find N2. So fine, it will be only one known, I agree, you are in the right path, but not A, but C, right? If you take C, N, this is N1. N1, he is asked to find N1 only, right? Not N2. So we better choose C, right? So torque from N2 will be 0 and I am not interested in it. The only unknown will be N1. N2 is another unknown, but it will not come in the equation. We are lucky. So that's how. Let's do it. So I will take point C. So torque from N1 plus torque from, just to be complete, I will write everything. Torque from N2 equal to 0 about the point C. So N1 about the point C. Let me choose some different colors so you'll not get confused. So let me take red. So torque from N1. So what is R for N1? From the point C, right? So the R will be this. How much is that? 1.2 meter from the feet, right? Yeah, 1.2. This, right? It's not, yeah, here, okay. So I will get the magnitude first. This is the R multiplied by the perpendicular force. It's already perpendicular. So that is the unknown, N1. Sine. This is the magnitude. N1 stands for the magnitude, positive or negative. Positive. No, not positive. Come on. C is here, right? N1 is here. Don't get this. I don't know why it is difficult. I mean, probably after some practice, you'll get it, hopefully, okay? This is, everything else is look like this is the sort of tough point here, get the point is C, right? Keep that in mind, okay? Every question will be different, so it is negative. Maybe you are looking at the direction of the force and saying it is positive. That is the mistake you are making. No, you have to look at the torque, whether it is counterclockwise or counter. The force can be up, but the rotation can be negative, okay, clockwise. So it is negative. Right. Now we go to the next guy. Right. Now first we get the magnitude. So where is this guy? So this is the where the force is applied, and this is the point. So R2 will be this green line. How much is that? 1 multiplied by W, which is 68 multiplied by 9.8. Positive or negative? Positive or negative? Come on. This is the positive. Right. What about this one? You know why it is 0, right? Because R is 0. Because C is where you want to take the torque, and the force is also at the point C. So the R will be from C to C. That means you have a 0 length. And that's it. You solve it and get the answer. You don't have to do any algebra. You take your calculator. Okay, I use this negative 1.2 multiplied by, what do you do now? Unknown, x, plus, then I have to put the 168 multiplied by 9.8. That's it, equal, I don't have to write the 0, that's unnecessary, equal to 0. Just, you don't need to do any moving things around, okay? Just tell the calculator, solve it for me. Shift, calc. You know, this is not the answer, okay? Don't, this is very important. If you are using the calculator in the solving mode, you should know the steps. This is not the answer. This is the what was in the memory of X from previous operation. So you have to press this equal button, the operation. You should see X equal to something and L minus R equal to 0, then only it has solved it. So 555, yes, it is there. Right. Question 21. Even when the head is held erect, like here, its center of mass is not over the support. It is to the front of your, okay, forward. So that's why we need some muscle from the back of the skull to pull it back. Otherwise, it will fall. See, above the support, it is your center of gravity or the center of mass is front of that, okay, towards the mouth or towards the. So if you don't have the muscle supporting it because of the, say, clockwise torque from the weight of the skull, it will fall. Who is stopping it from falling? This muscle. I keep, yeah, here we have all the names. Atlanto-occipital joint, that is the support. The muscle name is not there. Anyway, somebody find it out for me, okay, all right. Trapeze something, I can't remember, trapezius or something. Right, so this is an easy one. I told you, right, what you have to remember is when the fulcrum or the support is in the center, class 1. When the load is in the center, class 2. When the effort is in the center, class 3. So this is this one. So the answer is class 1. Now it's a continuation of the same. Now we are going to answer it. Now it's very cleanly written. So, you know, the whole skull is simplified to just a rod. In this rod, we have a force here from the support, and we have a muscle which is pulling it up. This support, yeah, at the support there will be forces, but I will not show the forces. Of course, there are forces. This is the support, okay? So, because I'm going to take the equilibrium condition around the support, okay? Let me call it P, just a label. And here is the weight. So I will say, to answer the question, because he is asking calculate the force Fm exerted by these muscles using the information in the figure. So he's asking to find, why am I getting the directions wrong? Okay. Yeah, it will be, muscle will be this way, not that way. So this is the force from the muscle, and this is the weight trying to rotate this way. Of course, there will be forces here, but I don't care because I'm going to take the equation net torque equal to 0 above the point P. So whatever the forces there, it is not going to bother me. The torque from those forces at the support will be 0. So it will be torque from Fm plus torque from forces at the pivot point, which is going to be 0, and the torque from the weight of the skull equal to 0 on the point P. So let me do it very quickly, unless you yeah. So Fm is the unknown. R will be what? 4.8 centimeter. So it's an equation. So I can say that the length is going to come each term. So there is no need to convert it into meters. It's an equation. I'm not asking to find the net torque. So an equation. So you don't really have to convert it into meters. So I will write 4.8. If you have done, it's fine, no problem. But you know, okay. Plus sign. Don't forget the sign. Is it positive or negative? This is the middle, and yeah, positive. And this one is 0, and the torque from W will be 48 Newton. This is going to be negative, right? So let me not put the sign now. Let me get the magnitude. It is, how much is this? That is the R now. Is it given? 2.3. Yeah, okay. Multiply by 48. It is negative, equal to 0. So, again, simple equation. You don't even need to, we can do the algebra if you want. It's not difficult, but you can use the calculator in the solid mode. Somebody tell me the answer. Come on. You want me to do it? Okay. Fm, I'll call it X. We don't know what it is. Multiply by 4.8. Let me ignore the 0 minus 2.3 multiplied by 48 equals 0. You don't do algebra. You just tell the calculator to do the algebra. Shift calc. This is not the answer, right? This is what you got from the previous operation. This is the answer, 23. Good. Right, we are done. Shall I stop? Right? Okay, because I have another class, I think, from, what's the time now? Yeah. We have time. Anyway. Oh, no, we finished the time, right? 40 minutes only. Yeah, okay. So let's call it a day, right?